Good morning, all. So, today we are going to discuss the concept of self and the mutual inductance. So, when come to the self inductance, first I have to write what is this phenomenon here. You take that statement here. It is the phenomenon of flux made by a coil linking to the coil itself, the coil itself, and and due to this linking an EMF is induced. So this is could be a typical statement you have to understand here. So I will take the very simple diagram and I've tried to explaining this one so that it will be very clear, very clear for us. So to understand this, so let us consider the coil. This coil has n turns. Let us consider the coil, and this coil has n turns. The number of turns of this coil has n turns, and this coil is being excited with some excitation, here. So as a moment this is excitation is done, so it is going to produce the current, and this current is flowing through this coil. So this is nothing but what? It is a coil. So whenever this current flow through this coil, then it is going to generate the you can say the magnetic field. So whenever the current flows through this coil, so it is going to generates this magnetic field. You can say. So this could be the direction of the magnetic field B. So that is the first point you have to understand here. So whenever the current flowing through this coil, then this coil is going to create or produce a magnetic field. So this magnetic field linking with this magnetic field is linking with the coil. This magnetic field is linking with this coil, therefore it is going to produce the flux pi. That is the second step here. So this current is flowing through this coil, so then this coil is going to produce the magnetic field. As a moment this magnetic field is linking with this coil, so it is going to produce the flux pi. If suppose is there any a change in the current, if there any change in this current, so then if there any change in this current, then there is a change in the magnetic flux field. As there is a change in this magnetic field, therefore this flux is going to change. So if the rate of change of this flux is linking with this coil, is going to induce the EMF. It is according to that Faraday's law. So this is what the actual phenomena which is occurs inside the coil. So let me to write what are the all points what we have discussed respect to this diagram. The first phenomenon which is occurring in this coil is the current through a coil generates the magnetic field, magnetic field, magnetic field. Then the second point here is the magnetic field, magnetic field linking through a coil, linking through a coil, create a flux, create a flux pi. That pi is the depending upon the that magnetic field and the area of that formula, I can say. Then what is the third point here? You can understand here. The third phenomena which is occurring in this coil is that if there any change, if there any change in the flux, linked to a coil, then EMF is induced. So this is because of the Faraday's law effect. You can call here. If you observe here, at the moment current through the coil is flowing, is going to creating the magnetic field here. As this magnetic field is linking with this coil again, is going to produce that magnetic flux here. And if any chance, by chance, there is a change in this current, therefore there is a change in this magnetic field. As a result, there is a change in this flux. If this change in flux is again linking with this coil, then it is going to induce the EMF. So this is what the phenomenon which is occurring in this coil here. So how to understand one note here, can call it is a note, because in all these three phenomenons, phenomenon, the coil has, right, the phenomenon has a coil, isn't it? Coil is creating the magnetic field, and again this magnetic field linking with the coil, and then again this coil is creating that magnetic flux, and the rate of change of this magnetic flux again linking with that coil, and it is inducing the EMF. It means in all these 3 points what we have discussed here it is common to a coil. So you can say it is a common to a coil. So you can write here, the coil has produced flux. The coil has produced this magnetic field, and again linking with same coil and create magnetic flux. So this is what we understand from this above concept. So here we have need to understand one more concept is called the self-inductance. Self-induction. So what is this mean by the self-induction here is, so according to this Faraday's law, as we know that the EMF it induced here, this EMF induced due to its own magnetic field or flux is called self-induction. So that is the definition you can call what is mean by self induction here is, so as this coil is producing this magnetic field or magnetic flux, due to this magnetic field and magnetic flux, again this coil is linking with itself and it is inducing the EMF. So that is the phenomenon, it is called the self induction of phenomenon it is called. Then what is this self inductance is here? Self inductance is, so as you know that self inductance what we have written in the at the early first point here, it is the phenomenon of flux made by a coil linking to the coil itself, and due to this it is EMF is produced. So you can say due to this flux made by a coil linking to the same coil itself, so that is called that self inductance. And we have to derive what is this self inductance here. So as we know that, so induced, whatever the induced or induced flux pi is directly proportional to the current I, because I can write here as my current increases, this flux also going to be increases because my flux magnetic field is increasing. So I can say my flux induced flux pi is directly proportional to I. If you remove this proportionality constant, then I can write here some L into I, where L is called a self coefficient, where L is called a self coefficient of inductance, you can say inductor, self coefficient of the inductor, you can call like this. Then L also can be written as here, this is pi by I. If this coil has a number of turns is N, this coil has the how many number of turns it has? N. So you can multiply here simply with N. So this is called the self inductance of the coil, and this self inductance of this coil is only depends on the number of turns, that flux and the current flowing through this coil, where L is called a self inductance, is called a self inductance. So this is what you can define what is meant by the self inductance here. So similarly you can define the self inductance derivation also can be possible, you can derive that one. So to derive this one, so let us assume I have a coil, n turns is there. So this is the current is flowing through this one. So this is going to create a flux, right? This is the red flux pi is going to be creating in the this coil, and according to this Faraday's law, the EMF induced in this coil E is equal to is nothing but it is the rate of change of the flux, isn't it? So that is the EMF. So how many number of coils it has? So it has a n number, so I can write n d pi by dt. But here I have to show this EMF with some negative polarity here. What is this minus is going to show is, it is that polarity is coming here according to this Lenz law, because the Lenz law always define that whatever the EMF induced in this coil is opposes the cause, which this E is going to opposes the cause. What is the cause here? Because of this supply voltage, this EMF is inducing it. So this is obviously this EMF is going to opposes this cause. So that's why that polarity is going to show that according to the Lenz law, E is equal to n d pi by dt. So that is the exact representation you can show here, or you can write simply the EMF is equal to n d pi by dt. So this is what the expression for EMF. And we also know that if you want to write what is the induced voltage in this coil, induced voltage E in this coil with respect to L and the current expression relation, if you see this one, we have a relation E is equal to L di by dt. So this is also one of the expression we know. And this expression equal to this expression, if you make it these two equations are equal length, then we are getting it is L is equal to N pi by I is called that Henry's. So this is also the inductance expression, the self inductance expression what we are getting from this one and this one, both are the same. So this is the way you can derive in different manner here. Now, and you also know that the magnetic flux density B is equal to pi by A. This definition you already know. From this you can write the pi is equal to B into A. Like that also you can write, or pi is equal to, instead of B you can write mu into H into A, or pi is equal to, this one is nothing but mu naught mu r H into A. So like that, so many relation you can try to bring from this diagram. Then L is equal to, I can write N into, instead of this pi I can write this one, so mu naught mu r H A by H A by I. So like that I can write here. Again, instead of H I can write, it is nothing but mmf per unit length, or you can say Ni by L also I can write. So I can replace this one here. So what you are getting here, it is the final expression I'm writing here. So this is coming mu naught mu r I n A by L. You can write something like this. Then you can, this is what is coming, this is what the coming square here, right? It is coming square here. You can show it is a square, is comes here like this. Then what is the final expression we are getting for L is equal to inductance N square by, it is L by, if you just manipulate this expression, then mu r into A will come, or N square by, instead of this whole term you can write it is a reluctance. So this is also the one of the inductance expression you can derive here. And I hope you understood, this is the mathematical derivation for the self inductance. And what is the self inductance here? It is the inductance of the coil due to the magnetic flux produced by itself, and it is linking with that coil. So that is what the phenomenon you have to understand here. So after this we'll go to see what is the mutual inductance concept here. Mutual inductance. We'll see what is this meant by a mutual inductance. Suppose you have the one coil. So this is the coil I just want to show here. This is the one coil, and so this is also the another coil I have, which is approximately placed at the first coil. This is the coil 1 and have excitation here. I can say it is the coil 1. This is the coil 2 I'm taking, and this coil has N1 turns and this coil has N2 turns, number of turns I can assume, and coil 1 and coil 2 are placing at near to each other or proximity to each other. Then this first coil, if I exciting with some EMF here, so it is going to carrying some current I1. So due to this current I1 in this coil is going to create this magnetic field. So this is what the magnetic field is going to creating in this coil. So this is the magnetic field, that is I can say B1. So B1 is the magnetic field created due to this coil 1 due to this current I1. So this is what I just want to see here. So after this magnetic field is linking with this first coil, so it is going to create the the magnetic flux, I can write it is pi 11. So pi 11 is the magnetic flux created due to the linking of this magnetic field in this coil 1. Similarly, so same this magnetic field, it is linking with the second coil, therefore it is also going to produce the it is also going to create the magnetic flux that I can write pi 21. I can write it is a pi 21. So I so you can understand here it is. So have the two coils which are approximately placed to each other, and current is flowing through this first coil. So due to this current I1, this is the magnetic field is created. The magnetic field is created due to this first coil, and this magnetic field is linking with the first coil, so it is creating the flux pi 11, and same magnetic field is, which is because this coil is placing near to this first coil, therefore it is also this magnetic field is linking with the second coil. So this, due to that, it is going to produce the create the magnetic flux is pi 21. Suppose if it is this second coil, if it is a completely shorted, it is completely closed, therefore it is going to carry some current. If it is carry some current as well, and according to the Faraday's law, it is also induces the EMF here as well. So that is what you have to understand the point. So this is what the concept I have getting from this diagram at the moment. So whenever the current flowing this due to the first coil, so due to this one, there is a flux is going to produced in the second coil. So you can understand here the current in this coil 1, then I can write here what is this pi 21 is nothing but this flux pi 21 is depends on the B1, and the B1 is depends on the I1, isn't it? If you increase this I1, so it is going to increase the magnetic field strength, then this magnetic field strength is linking with the second coil, therefore this is also going to increases. So vice versa, decrease or increase, whatever it is. So that can be possible. So I can write here is that my pi 21 is directly proportional to I1. So this is what I am writing from this statement pi 21. If you remove this proportionality constant, then what you are going to get is that is called that m into I1. M into I1. What is this m here? This m is called a constant of this coupling of the coils called coefficient of mutual inductance. Coefficient of mutual inductance. Coefficient of mutual inductance, and you can define this one, right? So I can write pi 21 is equal to instead of m, I can write m21 into I1. It means that my m21 is equal to pi 21 by I1. It means here you can say that, so the mutual inductance in the second coil due to the current in the first coil, this is the inductance which is going to be obtained here. So how will you define this one? Here is the mutual inductance is a phenomenon. Mutual inductance is a phenomenon in which flux linked to coil, where is according to current changes in other coil in its proximity. So this is what you can understand here. So as we know that here, so this should, due to this current in this first coil, it is producing this magnetic field, and due to this magnetic field, so this is the this magnetic flux has been created. Due to this magnetic flux is linking with the second coil, it is going to producing that the inductance. That is, inductance is called a mutual inductance. So that is the point we have to understand here, and we know that how to define this one, and we know that the induced EMF can be written as minus d pi by dt. You can write, if you have assume n is equal to the number of turns equal to 1, if you assume, then this is the expression is coming, minus d by dt. Instead of this pi, if I take this one, then it is coming like m into I1 will come. Then if it is E2, if I represent this one, then minus m, this is 2 1 d by dt I1. So this is what the EMF is coming. This E2 is nothing but the mutual induced EMF. Mutual induced EMF. So this is what the mutual inductance and mutual induced EMF concept you can able to understand from this concept, what is meant by mutual inductance. So this is what we are talking with respect to the first coil. This is the amount of M21 is the mutual inductance is coming. Suppose if you take the second coil and if you excite with this one, then there is also some mutual inductance can be possible. So that is also you can see. So as a result, you can see these things. So let me to draw the simple diagram, and I will define the both the mutual inductance of these two coils. So it will be very easy to understand for us. So I'm assuming that, so this is the V1 voltage and it is the V2 voltage is there, the same at a time. This is the current, I can say I1 is flowing through this coil. This is the N1 turn coil is there, and I can say, and due to this coil I1, so there is a I can say the magnetic field is going to be creating here, and due to this magnetic field, again the coil 1 and coil 2, you can say magnetic, it's going to create a magnetic flux here. So assume this is the pi 1 is the magnetic flux created in the coil 1, and pi, you can say it is the pi 21 is the magnetic flux is created in the second coil due to the current in the first coil. So that is the what I just want to say here. Now I will take the second coil. So this is again I'm exciting with this coil with the some voltage V2 here. So there is a current, I can say it is I2 is the current is flowing in this coil. Due to this current in this second coil, it is also creating a magnetic field around the two coils here. So here you can say this is the pi 22 is the flux is created due to this current I2 in the second coil, and here you can say it is the pi 12 is the flux which is going to creating in the first coil due to the second coil current. So that is what the concept you have understood mutual inductance in this case. So from these expressions of, so after getting all this concept here, so this is the number of turns is N2 of this second coil. then you can write what is the self inductance of the first coil. The self inductance of the first coil, you can say L11, then it is written as N1, and you can say d pi 1 1 by dt. You can write like this, or this is also nothing but L11 is N1 pi 1 1 by I1. So this is the self inductance you can define from this one. Then what is the mutual inductance with respect to this same second coil? So you can say M12 here. This is nothing but the number of turns of the second coil is N2, and this is coming here, it is pi 21. It is the pi 21 by the second coil current. This is the I1. So this is the mutual inductance in the coil 2 with respect to the current in the first coil, you can define. Then what is the self inductance of the second coil? Self inductance of the second coil L22 is equal to nothing but, you can say N2 pi 22 by I2, you can write. Then what is the self inductance of the second coil? In the first coil due to the second coil is nothing but, it is N1 pi 12, you can say this is the pi 12 by this I2. So you can say here, so this is the self inductance in the second coil, self inductance in the second coil. So due to the EMF induced the current in the first coil. So this is a little modification here, so you can show here. So this is nothing but M21, and this is the 12, right? Because so self inductance and the mutual inductance due to the second coil in the first coil. So it is the M12. So this is what the expression you can get. This is the self inductance of the first coil and mutual inductance of the second coil due to the first coil current, and this is the self inductance of the second coil, and this is the mutual inductance in the first coil due to the current in the second coil. So this is what you can easily understand what is the mean by self inductance and mutual inductance in this concept. Now let me to see what is the relation between your self inductance and the mutual inductance. To understand this, so let us consider this expression now, this one, and we'll try to do the relation between the self inductance and mutual inductance here. So I'm taking this M12 is equal to, is coming here, it is N1 pi 12 by I2, you can write, or you can also has this pi 12 is nothing but, it is some k times of pi 22. So you simplify, you can substitute here. Then what is you are going to get here? Pi 12 is equal to k N1, and instead of this one pi 12 you are going to get this k, and this is also you can write here, this is pi 22 by I2, you can write here, right? So I can again k is equal to N1. So this is you nothing but, you can write it is the B2 into A by I2, you can write, or further it is also simplified here, then it is coming k N1 N2 mu naught mu r into A by L. So this is what I'm writing here. So further this B is nothing but, mu into H. So B2 into H2, something like that you can write, or mu naught mu r mmf by a length. So a number of ampere turns by I by length. So this is what the expressions you can get, and you can simplify this one, then you are going to get this expression M12 is equal to k into N1 N2 mu naught mu r by A. This is the expression for the M12. Similarly if you do what is the M21, then for this one also you will get the same expression, K is equal to N1 N2 mu naught mu R A by L. So this is what again you are going to get. This is the second equation. And if you multiply this equation 1 and the equation 2, then what is the possible scenario here? M12 multiply with M21. So this is nothing but K square. I can write it is N1 square by L by mu naught mu R A. So something like this I can write. And N2 square by L by again mu naught mu R into A. So this is the kind of expressions I can try to writing here. So these two are the mutual inductance, so I can take it as a assume it is a mutual inductance square, then this is going to come in square. So what is the expression for this one? So this is nothing but the inductance of the first coil L1, and this is the expression is going to talk is nothing but inductance of the second coil, isn't it? This is L is nothing but N square by reluctance, isn't it? So reluctance is nothing but L by mu naught into mu R into A. So that is the kind of concept being already discussed in the earlier classes. So this is what the final expression we are going to get here. So if you want to write what is this K is nothing but you can write M by under root of L1 into L2. So this is what I'm trying to writing here. K is equal to, if suppose K is equal to 1, it means that K is equal to 1 means the coefficient of coupling constant, it is called a K is called a coupling constant between the coil 1 and coil 2. Therefore K is equal to 1 means the coefficient of coupling between the coils is strongly the coil 1 and coil 2 has been coupled to each other. Therefore the coefficient of coupling K is equal to going to be coming K is equal to 1. Then what is the equation? Then what could be this equation is going to be? So it is K is equal to 1, therefore M is equal to is coming under root of L1 into L2, where M is mutual inductance, L1 and L2 are the self inductance of the first coil as well as the second coil. So here if K is equal to coefficient of coupling is equal to 1, it means that both the coils are strongly coupled to each other. So that time your pi 1 is equal to pi 1 2 or pi 2 is equal to pi 2 1. So this is also the condition you can able to understand here. So with this I think I have understood what is mean by the self inductance and what is mean by the mutual inductance, as well as the what is mean by your the relation between the self inductance and mutual inductance. So with this I will conclude this class for the today's session.